So today we are going to do Planck's constant experiment. The aim of the experiment is to find the Planck's constant using the photocell. We have only three apparatus, that is the photoelectric unit, photocell, bulb and filters. The connections are very simple and I'll show you the connections. So this is the voltmeter ammeter. This is the photocell and that's the source of the light. These things are the filters which we'll be using to determine the values. So the connections are simple. Basically you connect the positive of this photocell to negative of the voltmeter, and then positive of the voltmeter to positive of the ammeter, and the remaining terminals you connect it directly. Okay, the procedure is very simple. We first take a filter and we just insert it in the photocell over here, and then we check the readings over here. So the correspondingly voltmeter reading, we find it to be this at the minimum. When this is at the minimum, we find this to be at 0, and correspondingly you will take down the ammeter reading. Then to make it a kind of easy, what I did was I increased this dial over here and checked where my ammeter reading goes to 0. When it almost reaches 0, I took down the corresponding voltmeter reading and divided it to the number of trials which ma'am had asked, and accordingly I went back to 0 over here, minimum over here, and then by particular that much step size I increased, and correspondingly I took the ammeter value till it became almost 0. So after for example, let's say our blue filter, we got our 0 ammeter reading. We change it to the next filter, green, and correspondingly we go for orange and red and repeat the same procedure. Now in order to calculate the Planck's constant graphically, we need to find the frequency of the corresponding color and the stopping potential. So the wavelength of the colors will be given. We know the frequency is nothing but speed of light over the particular lambda. We find the frequency, and our stopping potential is basically from our previous table where our ammeter reading is 0. So in this case it's like 0.755, 0.595 and so on. Now we plot a graph of frequency against the stopping potential. We get a linear graph. We find the slope of the graph and substitute the slope in the formula. H is equal to slope into E, where E is the charge of the electron.